Hi, I'm Lisa Reckoner. Welcome back to chemistry class. Today we're learning about free energy. Number one is, what is free energy? Free energy is energy available in a system to do work at a constant temperature or pressure. Free energy also indicates the spontaneity in the system, but that will be explained in question 2 or 3. Questions 2 through 6 are all about Gibbs free energy change equation. This is the equation. It starts with the delta G, which is Gibbs free energy change. Then it goes to delta H, which is enthalpy change, so it's the heat of the reaction. And you subtract that from the temperature in Kelvin multiplied by the delta S, which is the entropy change. Question 3 is all about delta G. Delta G indicates spontaneity. Spontaneity is whether there's external energy being put into the system or not. If delta G is greater than 0, then the system is non-spontaneous, meaning that free energy is absorbed. If delta G equals 0, then that means that the system is at equilibrium and energy is neither being absorbed or released. If delta G is less than 0, then the system is spontaneous. This means that free energy is being released. Question 4 focuses on delta H, which is the enthalpy change in a system. Enthalpy is the capacity to release heat. This enthalpy occurs in exothermic and endothermic reactions. Question number 5 is all about temperature, and in the Gibbs free energy change formula equation, it's going to be temperature in Kelvin. To find temperature by itself, you'd have to do the delta H divided by the delta S. Delta G isn't involved in this equation because it's assumed that it's going to be 0. Temperature is important because it can affect your spontaneity drastically. If your temperature times your delta S is greater than your delta H, then it's going to be a spontaneous reaction. That is easily demonstrated down here by the ice melting reaction. When the recording starts, the ice is at a temperature of -10 degrees Kelvin, and it is non-spontaneous, meaning that it releases energy. When it is at 0 degrees Celsius, it's at equilibrium. Nothing is really happening to the ice, it's just kind of sitting there. Once it's at 10 degrees Celsius, so it's like probably water at this point, mostly water, very warm, it is spontaneous and energy is being released, as you can see by the negative number here. Next is all about delta S, which is entropy change in the system. Entropy is the disordered gain/loss in the system. To truly understand what disorder is in a system, you'll have to look at the definitions for a positive delta S and a negative. A positive delta S means that the molecules are moving around freely within the system. For example, melting ice. Once the ice starts gaining heat, then the molecules start buzzing around again because it's turning into a liquid. This means that the disorder increased. Negative delta S's means that the molecules are slowing down and they start structuring themselves. An example of this is water turning into ice, not freezing water. I don't know what that's there. But when water freezes, it turns into those little cubes or whatever shape of the container that it's in. Usually it's cubes. And that means that the molecules within it are starting to structure themselves and just take an expanded shape. This means that the disorder has decreased in the system. That is all for our lesson on free energy.